So, I'm Dave Studia. I'm going to be talking tonight about positive behavior-driven development. I'm going to talk a bit about what that is, too. So, I've mirrored it a bit in the objective here. Attendees will not write bad tests anymore. Attendees will not write tests that take too long. Attendees will not... Attendees will understand basic behavior theory as applied to writing efficient, positive, behavior-driven tests. And so that's a bit about what this is. My background is, before I started programming, was as a behaviorist. And so I think about things in terms of positive behavior, which is essentially like, what is the thing you want to see, regardless of whether or not that thing is sort of inherently good or bad. In behaviorism, positive and negative, negative doesn't mean bad, it means the absence of something, right? And so the thing here is not all the things I don't want to see, it's what's the thing I want to see. As we go through this, you may kind of be reflecting on this, going like, this isn't new to me, I already do this. And one of my favorite things I've heard is Dave Thomas of the Manifesto for Agile Software Development and Practical Programmer, not of Wendy's, was on Code Newbie podcast like a year and a half ago or so, and he was talking about dry, which is a term he coined. And he was like, you know, the thing about dry is everyone takes it as this like hard and fast rule that you must follow every time you code. And he's like, that's not what it was supposed to be. It was supposed to be a name for this thing that we all experience where you code something and you code some more and you code some more and you go, oh shit, I've written the same thing 3 times. I could just go and abstract that into this one thing. It's just supposed to be a name for this thing that we all recognize. And so this is similar. Like you may go, I already do this. Well, excellent. And now you might have a name for it. So why listen to me? Well, the appeal to authority fallacy. I have a master's in education with a behavioral focus. I was a behaviorist for 7 years in schools and spent my entire time writing behavior plans and won an award for it. And right now I'm on the test automation team at Fanatics, Inc. And I'm going to do a quick shout out to Fanatics because we're hiring. We're going to be hiring 2 or 3 mid to senior full stack developers, although honestly, the team that we're hiring for uses Python, Go, Node, Mithril, just to be, I guess, especially ornery about stuff on the front end. Who here has heard of Mithril? Okay, yeah, so less than 50% of the audience. So they didn't really find anyone who like knows their stack, so they hire talented people. And Fanatics is a really cool company. What we do is we're the largest online retailer of licensed sports merchandise. So as an example, if you bought a Cubs hat when the Cubs won, you probably bought it from us. We run fansedge.com and fanatics.com and a bunch of other stuff, but we also have the manufacturing contract for all fan-worn stuff from Major League Baseball. So even if you bought a Cubs hat at Dick's Sporting Goods, we made it. So we're a massive company in that zone. Our sort of internal culture thing is by fans, for fans, although we just did an employee onboarding thing, and they were explaining that, and half the people in the room don't watch sports, so it's not critical. But if you're interested, either talk to me, or that's our recruiter, and she knows the guys at Click Talent and said it was okay that I showed this slide. So, yeah, I've got a couple cards, or you can write that down or talk to me at the end. So why think about behavior? Just in case, why write tests? So tests make your code better often. And I'm not a dogmatic TDD person, I'll get into this more in a second, but for me, I tend to write tests most often when I'm done with something to make sure I don't break it later, or to make sure someone else doesn't break it later. But it makes stuff more reliable. So then, test-driven development versus behavior-driven development. One of the best ways I've seen this stated is that TDD is the when. It's like in really dogmatic test-driven development, I'm writing my tests before I code. But behavior-driven development is the how. It's what kind of tests am I writing, how am I phrasing what I want to say and want to have happen. And I think that's really more theoretical than, like a lot of people say, oh, BDD is when you say should. That's not necessarily true. You can just do plain, straight up, true-false assertions, and it can still be behavior-driven development. But it's a good mental framework for writing purer functions. And I say purer because Yeah, you can, I'm also not a functional programming, like, absolutist, and I think that there are places where it really helps and some where it doesn't necessarily, and, but straight up, purer functions are easier to test. And so as you get writing more and better tests, you tend to start writing purer. So software doesn't get us. Pay attention. What does pay attention look like, anyone? How do you know I'm paying attention? Eye contact, okay, that's one thing. Feedback, I give you feedback, okay, I respond, I go, oh, interesting, yeah. What else? Huh? Body language, sure, yeah, you see, like, just beyond eye contact, like, my shoulders are squared off at you, I'm not sort of going, okay. So what we've just done is operationalize pay attention. We've really explicitly described that, right? And so for me coming into software, having worked with kids, like, you can't tell a kid, pay attention, because kids don't know what pay attention looks like most of the time. Even like middle schoolers and high schoolers, you think they should, but often, like, no one has ever said, like, paying attention looks like this, dude. And so neither does our software. We can't speak in these general terms, right? So the solution is excellent description of what we want to see, expected behavior, and of what we expect to happen if things go wrong, which is unexpected behavior. These are both positive behaviors. They're things we want to see, but some of them describe good stuff and some of them describe bad stuff, right? That makes sense? Okay. So some behavior basics. When we tend to think about behavior in behaviorism, we think of antecedent and behavior and consequence. So antecedent is the thing that happens right before the behavior, then there's the behavior, and then the consequence happens right after. And that lines up for those of you who have worked with Cucumber or some other BDD kind of frameworks, given, when, then, right? Given this thing has happened, what do I want to see happen, and then what should happen right afterwards? And so another thing that we do in behaviorism, we're talking about functional behavior assessments. Hey, functions, we know those. So basically it's going, all right, there's this assumption in behaviorism that every behavior has a function. It's attempting to achieve something. And so we go in and we try to look at a social situation with humans and we try to figure out what those things are. This antecedent happens and this behavior happens. Why did that happen? And then how can I manipulate the antecedents and consequences to change what the behavior is? And then we write a support plan. And tests are just a support plan for your software. You're going through and saying, for all of these given inputs, what would I expect to come out the other side? So in that guides then, hopefully, it changes the behavior. How do I write my functions so that I know what comes out on the other side? So the really important part here is that we own the inputs. Because unlike with humans, we can control the behavior. One of the best parts about shifting from kids to software is if something's screwing up, it's probably my fault. Mostly. I mean, we have dependencies, and those take away some of our control, and we have, weird user behavior that maybe we didn't foresee, and that takes away our control. We don't have full control. We have that department over there that wrote a service that doesn't provide a callback when it's done for some reason, right? Like, there's things we don't control, but we have a lot of control. And so when we're writing our tests, we need to own the inputs and the expected outputs. We need to, think about, okay, what could possibly come in? How am I going to react to it? And because we're writing them first, sometimes, I put write in here, but honestly, I've changed my mind since I wrote that. And so we don't know the behavior yet. We haven't written the code yet. If we have written the code, we kind of know what the behavior is, but part of the joy of going in, I say joy, and you may not feel this way, but I do, of going in and writing the tests, is that it sort of forces you to think about, oh, crap, I didn't think about that when I was writing the function. Like, I don't, it gets you to go back and handle things that you hadn't thought about before. Yeah, so again, and otherwise you end up with software that's Bart's engine. Because Bart was only ever told what not to do. And so there's a million, think of all the times that he was writing stuff on that chalkboard, and there's a million different behaviors that they want him not to do. Don't replace a candy heart with a frog. Don't do all the other stuff that he did. But if they just said, Bart, I just want you to sit in the desk eyes forward, hands on your pencil, right? If we do the positive behaviors, things become more efficient. And this is another favorite quote of mine on this. There's a million ways that things can go wrong. There's generally only a few ways that things can go right. And so if we focus on what's going to go right instead of what's going to go wrong, we get more efficient. So, I'm going to show a couple of bits of code. This was something I wrote. I went to Galvanize, and this was something I wrote towards the end. So this is the spec file for an API endpoint. And I've just got so many scenarios. When it should return an error when the email is already in the database. It should return an error if the email field is not filled out. It should return an error if the email is malformed. It should return an error if the password field is not filled out. It goes on and on and on. And when we wrote this, we did this really, really wonderfully in a very, very test-driven way. And so I wrote all those tests, and then my partner came up behind me and wrote this response for it. And like, this is the API endpoint that fulfills all those tests. And it's really great. It works. It is extremely robust. It's very difficult to break. But it's not really focused in the way that it could be. And that's not wonderful, so I'm just going to bring up the code. Oh my goodness, did it disappear off my desktop, or did I do this on my personal computer? On my personal computer. It's been a long day. All right, I'm going to summarize. So, I took all of those tests and condensed them down to 2. And so this test is still essentially the same. It should create a teacher user with all valid profile information included. I'm testing exactly what I want to see. If all the stuff is valid, then this is what should happen. And then if I'm writing in a really efficient way, I can say, it should return an error message otherwise. Like if I don't get exactly what I want, I just should get some sort of message. You can go more detailed with this, and we could write out many more tests that are like the specific error message if you have a bunch of different errors, like your password's too long, whatever thing you want to get into. But then, more specifically, the code goes from handle all of these potential error cases to what do I want to see? If these things are all true, then I know I've gotten valid data. In which case, respond with positive. If they're not true, then respond with an error message. And again, we could build this out a little bit longer and say, here are some specific error messages I want to send. But it's just flipping from focusing on all those things that we don't want to see to just the things we do want to see that can really condense your code down and make it much more efficient. And so not only is it more efficient at runtime, it's also way more efficient at test time because I'm now no longer running like 85 unit tests, I'm running 2, right? And that makes it more likely, well, this could be good or bad depending on your opinion, it makes it more likely that you're going to spend time coding and not on Facebook waiting for the test to run on your CI system. Yeah, go for it.
One question, sir.
Sure.
Go back.
Yes.
If you don't test for all these different individual error in this input, you don't really know which case in your function is actually catching the mistake. Right? So if you're passing in a too short password, that's the first thing that the API actually tests for and then returns an error. You don't know it will also catch, I don't know, different display name that shouldn't be passed. So
Sure.
Is there a way of automating this, or maybe saying these are the positive cases, all the negative cases will be automatically handled by something, or generated maybe automatically?
Yeah, I mean, you could definitely abstract out. So like, I mean, what's going to happen here is if this all goes wrong, then you're going to get dropped down into your else if cases and else
The
cases.
first thing is that it tests is the body display name. If it's there, right?
Sure.
If it's not there, then it falls through. Anything else could also go wrong, and you would never have to test it unless you pass it valid display name. Right?
Yeah. So and so, let me think before I respond. It's been a long day.
Can you summarize the question?
Yeah, so essentially what Hans is asking is, but then how are you going to get good feedback? I mean, right, like or how are you going to get good error handling if we just drop from the one specific case to a very general error handler case, then I'm not going to know what went wrong necessarily. And so I guess what I'd say to that is, and this is going to go to my point, a quote I bring up at the end, but I'll just say it now.
I don't think that's the problem.
Okay.
The problem is that you're not feeding it all these different error cases that you were kind of
In the
solving
test,
at.
you're saying.
Yeah, so you're not feeding everything is valid but the password. Everything is valid but the display. You're just passing in a set of completely unacceptable shit, and then it cracks out at the first condition.
Sure. Okay. So what I'd say to that is a quote I was going to share at the end, which is "Test until fear turns to boredom," which is my favorite quote about testing. And I think the answer is like you would probably want more than 2 tests for this, but only do as many at that point as you fear. Right? Like what are the cases I think are most likely to come up, and what are the things that are most likely to completely break this thing, as opposed to. Oh, that's from outside. Okay. And I think that that's a strong place to continue talking, but we started late. So, so anyways, those are all of those things are still expected behaviors. I'm expecting it to return this error message, right? Like it should not break, duh. When we test things breaking, we're owning the inputs and asking what we expect the software to do given bad inputs, as opposed to trying to come up with all the various ways that things could break. When we focus on expected behaviors, it's more efficient. We end up with fewer tests, with fewer checks, and the joke I made earlier. And so, yeah, again, it goes to, like, we definitely want to still catch the big things, but if we're focusing on the thing we want to see, then I shouldn't have had the second beer. Now I'm losing my words. Like, we're sort of validating ahead of time, like this does work, or I can now shunt this off to some sort of error handler where I can go through everything else, and we get there faster. So, and this is especially true when you get to end-to-end and integration tests. Like the thing that I've been working on for the last 9 months is a UI test application that's testing our main platform at Fanatics, and so I mean when we're talking about adding testing time, like our longest test is only a minute. But you know, when you have 50 tests that are all between 30 seconds and a minute each, now your CI process has gotten way too long, and especially way too long for developers to wait to know whether or not their build passes, right? So at that point, it was about, okay, fear and boredom, right? The first thing that we did was test critical path, like here's our main chain through of the things that we know we want to happen, and then we went to do the right error messages come up and everything, but and we run that before we do a final push and build into like production. But on a check to check, hey, does my code pass? We just run critical path because we're focusing on what we expect to see. Yeah.
So you should have 2 like error test files, one is just it works, and one is like these are specific problems.
Sure, or an ability to skip tests as needed depending on what's running, and there's a bunch of different ways to configure that. Yeah. A thing I really want to give a shout out, especially because there were a couple of people talking about Selenium before this, and as in all things, because it just had to be today, I can't show it off because I only wrote my test for Chrome, and Chrome pushed out an update today. So this is a UI testing framework that is just amazing, and I'm going to bring up their GitHub page here. So it's a test automation thing that is written entirely in JavaScript and basically injects itself into the browser to run your tests. So you don't need browser drivers. It works in any browser that runs HTML5. It is really cool. You should go check it out. I had a demo to do, except the way it works is it launches a tab that is its own little server, and then it launches your site. And today Chrome pushed out an update that takes all your background tabs and restricts them, and that broke it in Chrome. So and I didn't have time to play with Chrome and figure out how you undo that. So anyways, Mike though is doing a lightning talk about it on Monday at some other meetup. At the HTML5 meetup. So you should go to that because he'll have time to get his demo correct with the new pusher. Yeah. Clearly I should turn updates off. But I will show you a little bit of the code that I've written for it. It's just incredible. If I hadn't already spent 9 months and my whole team hadn't spent 9 months building something on WebDriver.io, we would kill it now and do this. And in fact, one of my teammates who got shunted off to a different project immediately switched to this. Here's an example test. So it's just straight up ES6, JS, and it's just incredibly easy to work with and run. And the key thing from our perspective is that, like right now, we're in a weird thing with WebDriver where Selenium, to run Safari now, you have to have Selenium 3, but if you have Selenium 3, then you have to have the newest version of Firefox, and the newest version of Firefox throws an unget-aroundable error screen if you access an unsigned SSL certificate, and our department won't spring for signed SSL certificates for our dev environment, so that kind of problem. And this works. Let's see, it's 7:40. I have some other more general stuff about like good writing test practice that I could go through, but if there are questions, I feel like we should get to those first. Yeah, great. Sure.
So let's say you wanted to change your whole application and you're doing straight like searches on strings. So you run your test more functional so that way you're not hearing if a string says something that there's a string there, period, or change what that string is. So that way you get in the language, there's no problem. IDs, what string values are. Using a testing framework that can accommodate writing something totally different.
Sure. I mean, there's a different tooling. I mean, like in JavaScript, I mean, if you write your tests in Mocha, you can run. Doesn't matter what you're running. You can run Mocha tests for WebDriver. You can run it for Angular. You can run it for React. I mean, it's just the framework. I think in terms of going between languages, the less tests you have, the less time you're going to spend rewriting them all. But they're going to have to be in something that can test that language.
And then, like, let's say your backend is Python, something like that. We just change it. There's no way to prevent that.
Yeah, no, I mean, if you switch languages for your whatever you're writing, it's going to be difficult. Do you know something?
Well, no, I was going to say, some of that is still
Sure.
if you're writing microservices, whatever.
I'm going to take the microphone off real quick. This is more democratic now.
I mean, if you're back in web services or HTTP or whatever, you can swap language, that should still work. It's just doing REST posts.
Yeah, totally. If you
But
put that
if
in
you
your
want,
language.
a lot of it really depending on what's the browser, what's JavaScript. You probably just push a new update that locks all background apps you want the services to do.
Yeah. Yeah, UI testing, man. Mike's just getting into that.
Sorry, you're really
making this around how awful it is.
So we're recording. Pull that.
Yeah, that's right.
Also, if you come back.
I have to restate every question so the mic gets it.
Thanks, Dave. Yeah, no problem. Just want to make sure I'm not drowning out everyone. You have a question over here?
Yeah, I was just kind of curious what your opinion is on bringing maybe search libraries like in your actual code as well as their tests. Like I see a lot, especially Ajax doing that.
Yeah.
So just like right at the top.
I mean, I say why not? If you can catch errors as quickly as possible, do it. And there was just an article about that, maybe not just the other day, but I just found it the other day, where the guy was talking about the benefits of bringing more test-driven development into game development, and the main conversation that sparked on my team was, why don't we bring more instant assertions in the code into non-game development? 'Cause I think that's, I mean, I haven't seen it in the wild because I don't work in game stuff, but like, I think it's a great idea. I mean, for me, it's like fail fast and fail informatively, and so that's as fast as you can fail is if you're doing it in the code, you know. And especially I think as things get more and more complex, and I mean, and let me see, someone who's more into UI UX maybe will speak to this a bit more, because I guess if you're throwing errors like that in runtime in someone's browser, they may not be super happy with it. But like there's a difference between a game crashing out and your website breaking, you know. But maybe as long as you handle the errors smoothly enough that things, you know, gracefully, that things continue. I think it's like that's as fast as you can fail, as if you fail right there. Does anyone else have opinions about that? Okay. No, so one of you saying like in game development especially, they'll bring assertion libraries into the code, like it won't be in the tests. Like there's not as many tests, and they'll just like, if this thing doesn't come through the way it ought to, fail right now at runtime. And so I was saying like, I think that's great because that's as fast as you can fail. But I think as long as you do it gracefully, like no one likes their app to crash out and get that stupid, like we exited the code one, you know. So the corollary is and fail informatively, so that people know why it has failed. Yeah. Anyway, thanks for the discussion. Yes, sir. Yeah, I mean, I don't know that I'd push back on the silent thing, but I'd consider it because, like, it'd be really nice to get back from Lodash. Here's what you did wrong. Like, here's why I'm failing. That's always my biggest frustration when building things is just that, like, okay, great, it errored out. What do I need to fix? You know, and I think that goes to Hans's point too, maybe kind of is like, if you just get one back one general statement and you don't have those things to catch. And I think it goes to like, the other test I'd probably write for that is like, specifically I want to know if the password's too short, then here's the password thing I should tell the user back on the UI side. But yeah, if I'm doing, especially around like data validation stuff. I think the next time I give this talk, I'm going to find it even better. My last time I did this, my examples were all like pseudocode and they were kind of bad and crap. So this time I found real code. The next time I think I'll do something that's not UI data validation because it would make more logical sense in the long term. All right, well, cool. If anyone thinks of anything else, then I'll just go through some of these because they're neat to see if you haven't seen them before. So kind of going to that too, like tests are your chance to set expectations for your code or whoever's coding your tests. And so sort of going to that, like, it's your chance to tell yourself, like, this is what I expect out of myself. So if my API I expect to fail informatively, then my res should come with the status and it should also come with a useful message. Because if you don't include that, it's probably not going to get included. So that's one of my feelings about writing good tests, and then I just got some of my favorite little things that I keep in a notes thing up when I'm writing tests, which is correct, goes to the next one. But essentially, like, what happens when you receive data that doesn't conform? Is the order important? Do things need to follow a range? Do they need to follow a reference? Or do they reference any code from any other unit? Is that code tested? Is it important if things are not null? Yeah, like, what happens when there are 0 things? What happens with 1? Does cardinality matter? And does time matter? And so I just sort of keep that as, like, when I'm writing tests, I keep going like, have I thought about all these things? And then this one too, fast, isolated, repeatable. And the isolated one, I think the one that gets skipped over a lot, like, mocking is a pain in the ass. And we should do it. Because otherwise you're not really testing the thing that you're testing. But that's my least favorite thing, is building up fake data. Self-verifying, if they pass, they should pass. And like we were talking, someone was talking about flaky UI tests, and that's, I'm in the middle of reading how Google tests software right now, and my favorite thing on that was when they get to they break tests into small, medium, and large. Is there anyone from Google here, perhaps? That can, no? Okay. But they're saying, like, if the large tests fail at an 85% success rate, then they're considered successful. Well, I was like, okay, great. Even Google hasn't figured out how to handle flaky UI tests. Good to know. Makes me feel a lot better. And they were like, and the guy who's writing the book is like, we're shooting in a 5-year period to get to 95%. And I'm like, great, still not 100. Okay, still making me feel better. And time, and I feel like this is the key thing, is like, even if you're not writing your tests before you write your code, it's really nice to be writing them as you write your code. Even, and for me, especially if you're spiking something or doing something for the first time, like, I only have the mental bandwidth to learn React or Jest right now. Like, I don't have the mental bandwidth to learn how to test React while I'm learning React. And so it's like totally okay to write something without testing it and then go back and refactor it with some tests later. That's not shameful. And yeah, so test expected behaviors. Think, what do I want to see out of my application? How can I focus my tests around that first? And then test until fear trigger support. Like, once you've got the right thing, you can go until you're like, this is probably not going to happen. Like, I was looking through those data validation tests, and we had a bunch of them that were like, make sure it's not a number. And I was like, but it's coming from our UI, and we're going to pass a string. Why did we do that? That was boring. And I know my partner got bored, so yeah, there's my contact info. And now I'm going to take off the mic. Mike? Okay.